You want it, say so. All right, last section in the chapter 1.6, absolute value. Most of you guys remember doing absolute value in Algebra 1. By definition, the absolute value is just the distance of a quantity from zero. So it's a distance away from zero. And most of you guys just know it as something positive. Whatever it is, you have to turn it positive. Well, kind of. It's because distance is never negative. It's always positive. Here we have some examples of absolute value equations. All you got to do is solve for x. What can x possibly be so that when it comes out, it's a 5? Well, with absolute value equations, you're always going to have two solutions. Well, sometimes two solutions or maybe zero solutions. All right, so we're going to go ahead and do both cases. To set up the first case, all you have to do is just rewrite the equation, but without the absolute value. So x is equal to 5. I know there's not a lot of solving there. But then the second case you have to do is write the equation, but set the answer equal to negative. So whatever's on the other side of the absolute value, you set it negative. So in this case, we're going to have two possible answers. X could be 5, or it could be negative 5. Because if you plug it back in, if you plug 5 into the absolute value of x, you do get 5. And if you plug negative 5 in, you also get 5. So two answers. Here's a more traditional question. The absolute value of x minus 7 is equal to 15. We still have two cases. There's the first case. You just rewrite the equation without the absolute value. X minus 7 is equal to 15. And then you would solve it like normal. Add 7 to both sides, you get 22. That's the first answer. To get the second answer, we write the equation again, but this time we change it to negative 15. There it is. I want to show you that negative. Okay, and then you solve that equation pretty easily. Add 7 to both sides. You get x equals negative 8. Now, the book asks you to plug those answers back in to check yourself. So it's always a good idea to check yourself. Take this 22, plug it back in there. 22 minus 7 is 15. Absolute value of 15 is just 15. Also, oops, wrong thing. Also, plug in the other answer. Plug in negative 8 here. See what happens. Negative 8 minus 7 is negative 15, but the absolute value of negative 15 turns out to be positive 15. So check. Both answers work. And that's not always going to be the case. Sometimes one answer will work, sometimes both answers will work, and sometimes none of the answers work. Let's do this one. The absolute value of 2x is equal to negative 4. Now I know a lot of you guys are setting up the two cases like that. 2x is equal to negative 4, like I asked you to, and then 2x is equal to positive 4. All right, but here's the thing. You have to think a little bit carefully. Remember I said earlier that absolute values can never be negative. And so when you try to solve this, nothing will work when you plug it back in. Because whenever you have absolute value, it should not ever come out negative. And so that one, if you look at it, you'll realize right away that it's not going to happen. So with this problem, the answer is no solution. All right, easy enough. All right, let's go ahead and do a few tricky ones. Here's our first tricky one. The absolute value of x plus 5 is equal to 2x minus 1. Again, we have two cases. there's the first case. Rewrite the equation without the absolute value and solve it. Subtract x from both sides, add 1 to the other side. You should get x equals 6. Pretty easy. The second case, though, remember you have to make the other side, the right side, negative. So the question is the same, except this negative that's right there. Okay, but that's not too tricky. Once you get it, just go ahead and solve. Distribute that negative x, or that negative in. When you distribute it in, that becomes negative, and that becomes positive. Okay, and then it's just algebra 1. Add 2x to both sides, subtract 5 from both sides. You get 3x is equal to negative 4. Divide both sides by 3. We get x equals negative 4 over 3. All right, let's do another one, another tricky one. The absolute value of 3x minus 1 plus 12 is equal to 10. The tricky part with this one is you have a plus 12 there. All right, so you have to get rid of that 12 first to isolate the absolute value bars. All right, and that's easy. You just subtract 12 from both sides. Once you subtract 12 from both sides, you have the absolute value of 3x minus 1 is equal to negative 12. And then hopefully you recognize that there is a negative now in the absolute value, or on the other side of the absolute value sign. So when we see a negative, we know it is no solution. Let's do one more tricky one. Here we have 4 times the absolute value of 5x minus 1 equals 60. Here's a little thing that I remember or noticed in the past years is a lot of people think, oh, absolute value bars is the same as parentheses where you distribute in this. That is a no-no. Do not distribute. It's not like parentheses. You cannot do that. What you can do is divide it to both sides. And that is good, because then you'll get rid of that 4. And we have something that looks like this. Now that the absolute value bar is isolated, we can do the 2 cases. Let's do the first case. 5x minus 1 is equal to 15. Add 1 divided by 5. Good. And then the second case. I put it down here because my face was blocking it in the second case spot. But you write this same equation down, but this time you put in that negative 15. Add 1 to both sides, divide both sides by 5. There are your 2 answers. All right, so not that tricky, but still I needed to show you. All right, let's do the same thing now, but with inequalities. So instead of an equal sign, we have a greater than, less than, greater than or equal to, less than or equal to sign. All right, here it is. Number 1, absolute value of x minus 12 is less than 17. We still have 2 cases. There's the first case. X minus 12 is less than 17. Solve it like normal. Pretty easy. The second case, though, you do have to make that 17 negative, and you have to flip the inequality. So now it's x minus 12 is greater than negative 17. All right. Remember that 2 things, change the 17 to negative and flip the inequality. Add 12 to both sides, you have x is greater than negative 5. That's not all the answer. Remember, with inequalities, we have to do something else. We have to put it on a number line. Again, always find 0. X is less than 29. Of course, I'm not going to make you count 29 units down, so put a slash somewhere here and say it is 29. And then the negative 5, I don't know, put a slash somewhere here and say negative 5. Okay? There are open circles. And then I guess x is less than 29 goes this way. And then x is greater than negative 5 goes this way. So it's barbells going in towards each other. Very nice. Let's do another example. This one is the same thing, except I wrote it on the wrong side or on the different side. And that sometimes confuses people, but it shouldn't. You just do it the same way. Two cases. The first case, 3 is greater than 2x minus 15. You have to keep everything the way it is so that when you subtract 15 from both sides, you get negative 12 is greater than 2x. Divide both sides by 2. You have negative 6 is greater than 2x. Here's the second one. Remember, not only did I have to change this to a negative 3, but I also flipped the inequality. Two things you have to do. And then you solve it. Subtract 15 from both sides. Divide both sides by 2. And there's our answer. Let's graph it. Again, always find 0. Negative 6, I don't know. You can put it somewhere here. It's an open circle. And then, so this is the tricky part when you're graphing. It says negative 6 is greater than x. So you have to be careful. This is the same thing as x is less than negative 6. So it actually goes this way. All right, let's do the other one. Negative 9, it's somewhere out here. It's open circle. And then again, you have to be careful. Negative 9 is less than x is the same thing as x is greater than negative 9. So greater than goes this way. So again, we have bars that go towards each other. Let's just fill this in. All right, I know that's a little messy, my fault. Let's do a few tricky ones now. We have absolute value of x plus 7 is less than negative 5. That doesn't seem tricky, it seems easy, but again, it is a little tricky because whenever you have absolute value, remember it always has to be a positive on this side. But it looks like it's saying that the absolute value of that thing is less than negative 5. Again, you can't have it less than 0, much less you can't have it less than negative 5. So this one is an automatic no solution. It cannot be less than negative 5. Here's another one. Oh, we have a negative, but it's actually different from the first one. This is saying the absolute value of 7x minus 2 is greater than negative 9. Well, if you think about it, I guess, isn't it always going to be greater than negative 9 just because you can't ever have it negative? So it's always going to have to be bigger than negative 9. All right, so in this case, even though it's a negative, the greater sign means it's always going to be true. So this whole number line is going to be filled in both ways. And you would write all real numbers. That's the symbol for all real numbers. All right, one more example. We have this one. Let's solve it out first before we break it into two cases. We first have to get rid of this 10, subtract 10 from both sides. Then we have to get rid of this 2, divide both sides by 2. And then we have the absolute value of x plus 6 is greater than 11. Okay, so that was just a regular problem. You break it up into two cases. The first case is x plus 6 is greater than 11. Solve it out. The second case is x plus 6 is less than negative 11. Solve it out. There are our two answers. This one you can graph. Here's 0. Here's 5. This one's an open circle, and it's greater than, so it goes this way. Here's negative 17, somewhere down here. Open circle, it's less than, so it goes this way. So it actually goes away from each other. All right, not too bad. All right, let's write some inequalities. So this is actually going a little bit backwards. They're going to give you the graph, and then they ask you to go backwards to write the equation. All right, this one's pretty easy because you have a dot at negative 12 and a dot at positive 12. So there's our answer. The absolute value of x is equal to 12 because negative 12 works and positive 12 works. This is kind of the same thing, except you have shading in between. How do you think that's going to change our equation, or actually our inequality? When you got the two dots and then they shade in. There it is. X, the absolute value of x is less than or equal to 12. When you go in, less than or equal to 12. What about this one? What about when they go away from each other? There it is. The absolute value of x is greater than or equal to 12. I hope you caught the mistake, because there is a mistake. This symbol is incorrect, because if you notice, this dot is open and this dot is open. So when they're open, it's only this symbol. It's not the equal to on the bottom. It's not underlined. Okay? That is good. All right, this is our last slide of the day. I know these notes today were super long. We're already at 17 minutes, but we'll get through this quickly. Compound inequalities. Write each compound inequality as an absolute value inequality. All right, so compound means you have two answers. I know it doesn't look like two answers, but 20 is an answer and 21 is an answer, but they want you to write an absolute value inequality for it. And here's how you do it. You're going to first find the average of the two numbers, the 20 plus 21. Again, to find the average, you add them together, and then you divide by 2. And that gives us this number, 20.5. The average. To get this number, you would find the distance from the average to this number. Or it's actually the distance to either number. So the distance from there to there, or the distance from here to here. In either case, the distance is 0.5 away. And so that's how you come up with the absolute value equation. Because if you solve this equation, you would get these two answers. So it's just another thing, another way of going backwards. Let's do another one, the last one for the day. Again, find the average between these two numbers, add them up and divide by 2, which is 18.5, that goes there. And then the distance from the 18.5 to there or to there is just 3 units. And there we have it. Absolute value of x minus 18.5 is less than or equal to 3. All right, that is all we have. I know the notes were kind of long today, almost 20 minutes now. Go ahead and try your homework. Come to the Zoom meeting if you need any help.